Continue curve sketching. Example, let's take a look at this function. Y is equal to x over sine x. Now we know that this function is an even function, so we just need to draw sketch the half of it, and the other half is the mirror image. Now if we consider directly that this function is periodic, and the function is not defined at those points, which is sine x equal to 0. So therefore, this function is not defined at the multiple of pi's. Right? So these are 1 pi, 2 pi, 3 pi, 4 pi. These will be asymptotes. Now, when x is at 0 is not defined, but when x is approaching to 0 from right, the limit it does exist is equal to 1, right? So this is a point. The function limit exists, but not a function. When x is equal to half pi, y equals to half pi. So this is the point. And when x is a 3 pi over 2, this will be negative 1. Therefore, y will be somewhere here. Okay. And when x equals to 5 pi over 2, and y will be equal to 5 pi over 2, somewhere there. When x equal to 7 pi over 2, y will be equal to negative 7 pi over 2, right? And so on. Now we can draw the curve that this is asymptote, right? The function is symmetrical to, so that one will be there, you know. And continue, well, when this is the point why the function, the curve passing through with these two asymptotes, and these will be two asymptotes, and two asymptotes, and so on. So this is more or less the curve of this function, right? We can imagine what, you know, what the curve can be extended and getting higher and higher. Now we can consider the curve this way. This function is the reciprocal of sine x over x. Sine x over x is the curve we sketched in the last episode. So this is the curve. This is the curve, sine x over x. So we just sketch the curve which is a reciprocal of this curve, right? So when x equals to 0, that is the point. The function does not exist, but the limit does, right? Then this is the point, the function passing through. This is decreasing, therefore this is increasing. This is 0, this is infinity. Just draw this reciprocal. This is the 1. And This point reciprocal, negative, so somewhere there, right? Because the reciprocal. This point, reciprocal, will be there, and decreasing is increasing, increasing is decreasing. 0 is not defined, and this one, this point reciprocal, is somewhere there, and the reciprocal of this curve is this. At 0 is not defined. Reciprocal is somewhere there. Okay. So that is another way of sketch this function, by using the reciprocal of the existing curve, which we have done last time. Okay, that is another way of sketch. Now there's another way. X over sine x is actually x times cosecant x. We draw cosecant first. Cosecant, and this is cosecant, right? Cosecant at 1, these are 0.1. This is -1, -1, but you know this cosecant function, just periodic, okay, reciprocal of sine. Then multiply by x, so x is my multiplier. You just modify the amplitude. So this function, well, 1 is here, right? 1 is a point which is not defined, but limit exists. And this is y equal to x, this is y equal to negative x, y equal to positive x, y equal to negative x. So this point is half pi, so this will be half pi. This is 3 pi over 2. This will be 3 pi over 2. This is 5 pi over 2. So this will be half pi over 2. And this will be 7 pi somewhere here. This point comes there. So we can sketch the curve. That will be this, right? This is the point. This is the point passing through. 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 This is the point it's passing through. So okay, this is another way of obtaining this curve by using x multiply cosecant. That means we have a cosecant curve just with x as a multiplier. You modify that cosecant curve by lifting accordingly on the y equals x and y equals negative x. And then using symmetry, we can have the other side. Okay, let's take a look at the graph from the internet. Now, let's consider this function, x over cosine x. This function is order function. So we just sketch half of it and the other half using symmetric with respect to the origin. Now, I'm not discussing all the detail because we're just simply using the similar technique as last example. we can use we can have a 3 method, but here we're just using one method. Okay, that is origin. So the function the function is defined. So it goes like this one, because at the half pi the denominator is 0. So this function is not defined at those points, which is cosine x equals 0. So at half pi, 3 pi over 2, 5 pi over 2, and so on. These points, the function is not defined. So we have an asymptote. And when x equals pi, cosine is negative, right? So you get a negative pi somewhere here. 2 pi, y will be 2 pi. 3 pi, y will be negative 3 pi. Excuse me, there's some noises in my neighbor. Okay, when x equals 4 pi, y will be 4 pi. So by considering the asymptote, this will be like this. See? Okay, and by considering symmetry, then you have on the other side, right? Yeah. And so on. Okay. Well, there are more examples to come, and thank you for your watching.